66 million years ago, a mile-wide asteroid struck Earth, ending the Cretaceous, wiping out nearly all the dinosaurs and roughly 3/4 of the planet's plants and animal species. And for the first time, a peer-reviewed scientific study studying the effects of the tsunamis created from this asteroid has been published. By utilizing the first global simulation of the tsunami and mixing in 100 sites of geological data from around the world, they found evidence that supports their model's predictions about the tsunami's path and power. These mega tsunamis, or shall I say monstrous tsunamis, were nearly a mile high, scouring all of the ocean floor thousands of miles away from the impact site. And to help mitigate any potential errors from the global simulations, the scientists went and looked at the distribution of erosions and hiatuses that were observed at the uppermost Cretaceous marine sediments, and they showed that they were consistent with the modelled results. And to help put things into perspective, the authors calculated that the initial energy in the impact tsunami was up to 30,000 times larger than the energy in the December 2004 Indian Ocean earthquake tsunami, killing more than 230,000 people, and is one of the largest tsunamis in the modern record. For the review of the geological record, they analysed published records from 165 marine boundary sections and were able to obtain usable information from 120 of them. And they found out that the most scouring occurred in the North Atlantic and the South Pacific, thousands of miles away from the impact crater. Of most significance was an outcrop found in New Zealand's North and South Islands, more than 12,000 kilometers away from the Yucatan impact site. If you thought the day after tomorrow was bad, think again. Around 2.5 minutes after the asteroid struck, a wall of water 2.8 miles high was formed. And according to the simulation, around 10 minutes later, a second wall of water would have formed, this time nearly 1 mile high, and this would have swept across the oceans in all directions. And according to the model, around 48 hours after impact, significant tsunami waves had reached most of the world's coastlines. This was truly a global event with global implications. A second study is already planned to model the extent of coastal erosion due to the tsunami worldwide. 66 million years ago would have been one of the scariest on record, and we can just thank the fact that we weren't there at that time. If you enjoyed this video, please consider subscribing and hit that like button. It really helps me out with the algorithm, and I'll see you in the next one.